Hi, welcome back to the C++ advanced C++ class. And uh, let me let us wait a few minutes. Several others are joining, so let me admit them. Okay, I think we can get started. Um, Hopefully, you have been doing great. I do see that most of you are have submitted your assignments, the labs. Few of you are still have not still submitted the labs, so I'm looking forward to to seeing your labs as soon as possible. I mean, the main thing with the lab is that, I mean, if you do the labs regularly, then you are not falling behind, and then you will you will get more and more stuff done. So that's why completing the lab in time is so much critical. So anyways, let me start sharing my screen and we can get started. Okay, so let me do the screen sharing. Yeah. Okay, so welcome back to object-oriented programming with C++. And then we have, during the last week, actually, we have learned the arrays, the introduction to the arrays, searching and sorting the arrays. And the Zoom recording is missing here. Oh no, it's there. So previous classes Zoom recording is there. So every week I try to upload the Zoom recording as soon as I receive it from Zoom, uh, the recorded material, and also I tried to upload some. Uh, I have uploaded only one video, but starting this week, I will try to upload multiple videos because now uh, the arrays, also the other stuff. I mean, arrays, the stuffs related to arrays and the searching and sorting arrays. All these things are pretty like your revision of whatever you have accomplished before. So right now things are getting more serious because we are now starting the pointers this week. So this is a really it's a big deal. I mean, it's a interesting aspect. I mean, there are a lot of things across the pointers. C++ is based on the pointers, so we will be learning a lot today regarding the pointers. So without further delay, let me start the presentation. And as we have done before, we will be hopping in and on with the live coding, so you can also understand as we discuss certain topics how we are making progress towards how can we make progress towards programming. So let me okay, yeah. So basically we are trying to get into the fact about the pointers. So I mean, first of all, we have to understand the pointers, right? I mean, basically the pointers are related to something like, if you have seen some variables like this ampersand. Let us say you have a variable int a equals 10. Okay, in your program, this type of variable declaration you have, and then what you can do is that suppose you wrote a function, let's say int um, do do it. I mean, let's say this is the function, and it's and you want a to be uh, you want a to pass there. So you can do in two ways. One thing is that you can do int x, and then you do something with the function and you return something, whatever you want to return. I mean, whatever result you want to return. Maybe you are doing um, return x times x. Now, this thing you can, this passing of the variable, you can do it in two ways. Number one is you pass the actual variable. So you pass by value of the variables. This is called pass by value, or otherwise you can always do pass by reference. So this reference is basically, this is the operator. This ampersand is an operator. This is called the address operator. It returns the memory address of the variable. So what happens here in the behind the scene is that you have, I mean, memory is everything. Whenever you do any computing, any IT related stuff, uh, operating system, you write a program, any language, memory is everything. So basically, whenever you define a variable a, you are reserving some space in the memory for a. We'll be discussing more about this. Normally what happens, for a variable of type character in C++, you have just 1 bytes of memory. If you have a variable of short, for example, the data type short, then you have 2 bytes of memory. If you have integer, for example, you have 4 bytes of memory. So this occupies 4 bytes of memory. And then if you have long, um, for example, long, you can have 8 byte. And what else? I mean, if you have, for example, um, so no, long is also 4 bytes. I'm sorry, 4 bytes. So if you have float, for example, float is 4 byte as well. Now, if you have double, for example, you have 8 bytes. I mean, you don't have to memorize this, but these are the memory. So memory is everything whenever you do that. So each byte of memory has a unique address. A variable's address is the address of the first byte allocated to that variable. So when you say ampersand, this symbol, or you pass by reference, you are basically passing the reference of the memory. So you have a is equal to 10. Your a equals 10 is stored in a memory cell. And this memory cell has an address. I mean, whatever address you have, hash coded address, whatever it is. So whenever you do and, that means you are passing it by this address. You are not passing the physical value, you are passing the address. Why you want to do that? Because you want to save the memory allocation. So you have already allocated certain amount of memory here, so you want to reuse that. And if you want to redefine that variable, let's say you have you have you calculate something, you will get of course the calculated value. Or maybe you have a void function, and you similarly you have some variable called int a equals 10, and your void function is something like void do function's name is do. You do, I mean, like int uh, reference of a, and you do something with to the a. You can say a equals, let's say, a plus 5. You incremented the variable by 5. You don't do anything because it's a void, so no return. So basically what happens, the variable that is originally stored here, the value of this variable gets modified. And so in the main program, of your C++ code, you can reclaim that variable after calling the function, the same variable, but with its modified value. So that's basically around why you want to do the pointers. I mean, do the reference, pass by reference. There is another advantage yet, like if you have a function and you have an array, for example, you are passing an array, and this array is like 10,000. The length is 10,000. Let us say you were writing a code for the Amazon e-commerce, I mean Amazon.com, and let's say for just sake of argument, they are using C++, and then you want to pass, you want to modify something on list of products, and that size of that list is 1 million. There are 1 million products there. Let us say, so then you should not pass by values, because then you have to carry the whole memory of 1 million array with your function transformation. So what you do, you just create the variable one time, and then you just pass the memory address, and then you manipulate the variable whatever the way your business wants, and then at the end the value is rewritten inside the memory without costing any additional memory. It will take some time, but it will not cost any additional memory. So that way you basically I mean save your memory, and your program is faster because of less memory usage. So that's pretty much the perspectives around the pointers. So the first thing is the getting the address of a variable. So as we discussed, I mean every variable is stored at unique address, like we discussed here. I mean every variable that you define, that is stored in an address in the memory. Memory is like, I mean basically whenever you think about a memory, your operating system has a virtual layout for the memory. Your physical memory resides somewhere on the hard disk part, on the hard disk basically. So there is a mapping between hard disk and your operating system, which is a software. So your memory is virtualized here. So when you store the variable, you store the variable inside the virtual memory when you run the code. So uh, once when you are running, it is stored inside the memory, and then getting the address is I mean that is accomplished by executing this command, I mean executing this particular statement. So if we just try to do something like that, I mean let's create let's open the folder. I think that should be there was a folder that I was working on, that is, let me go there fast. So here I think C++, no, not this one, this one classworks. So if I just open the program and create a file here, so let me create a file. Let's say the file name is what is the name of the file? I mean we can give any name to this file, but we can say uh, what did I do? Okay, here. So we can say the name is let's say p1, because pointer, we are talking about pointer p1.cpp. And once we get that, let me lower this terminal a little bit. So this is the thing, and then we can do include um, input output stream. As you know, I mean this is a standard thing, using namespace std, and then you can create your main function, this one, and then you can do int x equals 25, let's say. Now you can say that cout, I mean the address of x is, you can write like this one. Now So if you put an ampersand symbol ahead of the variable, that gives you the address. So if you so you created the code. Now if you want to run it, you can do it as follows. Let's maximize the screen, and then it's here. We can do g++, and then we can say p1.cpp. So, or we can do g++ dash o p1.exe, then p1.exe. If we run it, you can see the address is something like this. This is a memory address. It's just typically, you can see it's like a hash code. So whatever address it is like that. So this is basically you get when you do the ampersand sign. It is the address to the memory. And this address is unique. I mean, if you define another variable, let's say you define another variable y equals 15, and then uh, just store you just try to return the variable of y, I mean address of y. So what you can do here, sorry, what you can do here, um, I'm just saving the file, control s, and then if I run the file again, compiled it, and then if I run it, then you can see that there are two addresses, but they are different. They are not same. I mean, memory addresses are unique. So that's how the memory is configured. So that's basically the first example for the pointer. That's hello world for your reference operator. It's not pointer, but it's a reference operator. So now let's say there are uh, you can think about the pointer variables as well. I mean, you have different variables, I mean, and their addresses that we discussed. But I mean, the pointer variable is often just called a pointer. Now we have to understand the implication of the pointer variables. Now a pointer variable is sometimes called just a pointer. This is a special variable that holds a memory address. You know, there is a difference between the actual variable and the pointer variable. The actual variable is the variable that holds a value. Let's say you have an integer. You have an integer like you have this one, integer x equals 9. So basically, this is an actual variable that holds the value, the number, the value of a parameter. But the pointer variable, on the contrary, it holds a memory address. I mean, just as integer, just I said, I mean, integer is designed to hold integers. Doubles are designed to hold floating point numbers, decimal numbers. Pointer variables are designed to hold just the memory address, nothing else. Now, the memory addresses identify specific locations in the computer's memory. The pointer variable holds a memory address. That's why it can be used to hold the location of some other piece of data. This should give you a clue as to why it is called a pointer. It points to some piece of data that is stored in the computer's memory. Now, the pointer variables also can let you do some work with the data that they point to. you know so let's give some example. I mean, like uh, I mean, suppose you have an array. Okay, so what happens here, suppose, I mean, let's think about a situation. We are passing an array as an argument to a function here. This is the function name, and we are passing an array. This is the numbers is the array. So numbers is defined as, let's say, numbers. Let's say this is integer array, int numbers, and it's the size is defined by size, and you can define size in some other places. Maybe it is 10, 5, whatever it is. And I mean this array is maybe 1, 2, 3, 4, 5. These 5 variables it is holding. Let's say things are like that. Now, I mean, when we call the show value function here this way, right? So now the thing is, in this code, we are passing the name of the array, numbers, and its size as arguments to the show values function. So we are passing the actual array and its size. So you can define the function in this way. Maybe it is, yeah, here. You can define the function in this way. You can say void show values int, then you can say the values and int size. So that's how you can define the function. This is the signature of the function. So this is your definition of the function, and you are doing something here. We are not really uh, focusing on what we are doing inside the function. Rather, we are focusing on this passing of the variables. Now, in the function values parameter, this one values parameter um, receives the address of the numbers array. uh, it works, I mean, if in the function the values parameter receives the address of the numbers array, it works like a pointer because it points to the numbers array. Now let's see how it works. So what is going on here, you have this numbers array, right? You have this show value. Now if you have somehow if you have the address to this array, then you are practically passing the whole array to it. So the values of the parameter in the show values function points to the numbers array. So here um, you have your values are basically pointed to here, these numbers, not here to this number. Basically, to be precise, not exactly here. Let me delete this one, eraser, not specifically this one, but you are doing it like this address is pointed to the first element of the array. Now as you do that, I mean, you can also do the reference variables. I mean, like we discussed already before, the reference things, but it is why it is called we could do that. We are not discussing this, but we could do that. Why it is called a reference variable? Because it references another variable in the program. Now anything you do to the reference variable is actually done to the variable it references. So if you do that, it actually does something on the main variable itself, wherever you define it. Now, suppose you have the, I mean, let's not, let's get back to this particular example. So, uh, so basically, what is in stake here is that whenever you are passing an array, you are passing an array to a variable. That means you are essentially store I mean, you are essentially passing the memory address of the numbers to this function whenever you are doing that. And the memory address is basically the address to the first element in the array. We'll discuss more about this. Now, there is a strong relationship between the arrays and the functions, arrays and the pointers. So uh, now the name of the arrays can be used as constant pointers, and pointers can be used as the array names. Why we are saying that? Basically, uh, you know that an array name, we have already discussed the array, without any brackets and subscript actually represent the starting address of the array. So basically what happens, if you have an array defined like you have x9, let us say 9 variables, and you are defining 9 variables in this way, whatever you have there. So if you just see out x, then you are basically outputting the first variable. So what does that mean? It means that the the pointer to this variable, I mean the pointer to this variable the memory address to this variable or pointer to this variable is pointed towards the first variable in the array, you know. So basically what we want to do here from this point actually, I mean, you can write a program like this one. Let's try to create a program like uh, uh, create a different program to illustrate this one. So let's change it, and then we can say create another program. Let's say p2.cpp. So what we are going to do, first of all, we are doing include. Um, just a second. Okay, yeah. So let's do include, and then we do input output stream, IO stream, and then we do usual thing using namespace std. Okay, so we do int main. That's usual stuff. Return 0. That's the skeleton of our program. Now what we can do here, we can simply start coding our stuff. So we can say short numbers equals let's say 10, 20, 30, 40, 50. Let's say we are defining an array. Now you want to find the first element of the array. In order to find the first element of the array, what you need to do is that cout, and you do uh, use a star and then use the numbers. Let's do it in this way. I will discuss more as we make more progress. So if we do that, and then if we try to run the code, we can get it as follows. Now we can do g++-o uh, p2.exe, and then we can do p2.cpp. So once we do that, we can do dot p2.exe. Then you can see that you are getting 10. So basically what we learned here, uh, I mean, let's make a little bit of progress here. So what we just a moment. So what we learned here is that we sorry, what where did my other stuff go? Maybe it's here. Yep. So as we referencing an array, when we just write in this way, like cout, and then we use a star symbol, and we use the array, the name of the array, then this star symbol is basically pointer. It is the pointer to the first space, first element of this array in the memory, and that's how it is printing out. So you can say that cout, when you do star numbers end line, then you are getting the first element. So this is how you are handling the pointers in C++. So how do you define the pointers? So basically you define the pointer as follows. You write int, and then you use the star symbol, and then you put the pointer name. Now this star symbol, what does it mean? This star symbol means it is a pointer. Now is the type, what is this variable intptr? This is the pointer to a particular integer variable. That's why you are using integer here. You are not using, I mean, it does not mean that pointer has a type of integer. It means that this pointer, this is a pointer variable which is pointed to an integer variable. So this one can hold the address of an integer. Now spacing in definition does not matter. I mean, you can do it in this way. Some people want to do it in that way. That way, maybe it is more apparent that it is a pointer to an integer rather than it's a pointer. So once you do that, then you are assigning an address to the pointer variable in this way. You write integer, then you do star integer pointer, I mean that way. And then if you do that, so what happens here, you have the number stored here, 25. Your pointer is basically this one. It is pointed to, I mean, this is the address of the memory. So your address of number is basically this one. So your pointer, it will return you the address to the number, which will be done by ampersand symbol. So if you want to find out the address, this pointer, the value of the pointer, then you have to reference the variable and using the reference operator. C++ is very, very efficient to reference something to the memory. You don't have to do extra coding for that. So this is another way you can find the, I mean, another way you can tag your, I mean, you can basically point your variable to a specific location in the memory. That is by defining this pointer, and then I mean, you can do the pointer in this way. I mean, you can get the value of this pointer in this way. Now, it is always a best practice to define the, I mean, to initialize the pointer, which will come later. I'm going to discuss. So, is there any question related to how you define the pointer? So what we learned here, I mean, again, I'm reminding you, first we started with reference. We are hopping very fast, actually. That's why something maybe may seem to be disconnected a little bit, because I think that this reference variable you have already covered in your previous C++ class. So we talked about reference variable. Then we talked about the array, and we mentioned that if we have an array and you pass an array to the to a function, then basically you are passing the memory address. When you pass the array, you are passing the memory address to the function, and then along with the whenever it gets the first element, it carries all the elements along with this through that memory location. That's second thing. And as a third thing, we want to really define the memory address in terms of the pointer. So pointer, it's a new concept in C++. What does a pointer mean in real life? Suppose you have two objects. I mean, let us say there are two any objects. I mean, here. Now, if you have a pointer, it is basically locating, it is basically pointing to this object one, or you can define another pointer which is located. I'm just, this is one type of pointer. This is another pointer. Let us say this is an integer variable. This is a float variable. That's why I showed different line style, but it does not mean that it is broken or something like that. So this is another pointer. So in C++, this symbolic notation, it is the compiler makes it in a way that you can use the star symbol in the language to point to a pointer, to pointer for a variable. Now you define integer star int ptr. What does it mean? Your int ptr is always a address to the memory. It is not an integer. This variable intptr is not an integer. It's this type of notation simply means that intptr is a pointer to an integer variable. Similarly, you could do double pointer. You can say dptr. So that means your dptr is a pointer to a double variable. You have to just understand the difference. In no way dptr has a type double or intptr has a type integer. This type of notation simply means int ptr is a pointer to an integer variable and dptr is a pointer to a double variable. Any confusion, any question, any comment? Okay, let's move forward. So we know the pointer variable. Now, just before we have mentioned that it is the best practice in C++ to initialize the pointer variables. Now, how do you initialize? It is initialized to the null pointer. What is a null pointer? This null pointer is a keyword. I mean, it represents the address 0. I mean, the epoch. It represents the epoch address. It contains nothing. So what you do here, the way you should be using the pointer is you first define the pointer variable in this way, then you do the subsequent coding. So let's say let's write a code. Let's write an example around that, and then we will accelerate a little bit. So uh, let's say let's create another program. Let's say p3.cpp, and there what we do, basically you can do the same thing like I'm just copying and pasting it from the previous program, this one, and then int main return 0. And then what we can do here is basically we can define a variable x equals 25, let us say. Then you define a pointer int star ptr equals, first you define it as a null pointer. Okay, this is your initialization. Null pointer, null ptr is a keyword in C++ which represents the address to the 0, I mean to the memory location 0. Means nothing. I mean it's void memory. So now what you can do, ptr, you can define it as ampersand x. That way this ptr will contain the address to the variable x. Okay, now what you can do, you can always write cout. Okay, um, you can say that I mean address, and then you can say ptr end line. So if you do that, I mean, of course, if you print x, it will print the value. There is no doubt in that. But if you do the ptr, then it will be simply like this one. Let's say p3.exe and p3.exe here. So that way, uh, p3. So you can see the address is this one. This is the memory location where x is located at. Okay, that's how you define the ptr. That's absolutely, that's how you define the ptr. So any idea what if you do the star ptr, what would it do? Let's see, let's try. If it crashes, it does something. So you can see that it will print the actual number. What does that mean? So initially when we did that, to remove the confusion, let's write it twice. Okay, I'm just jumping into different topics, I mean fast, so that you learn it by example rather than learn it through listening somebody's lecture. So you see here, you just write the code. Let me do it in a better way. So your code is like that. So you have pointer, this is the memory location. So your pointer should be whatever memory location. Now if you do a star ptr, what does it mean? So if you compile it and if you run it, you see that you have the value first, and then you have I mean you have the address here, but you have the actual value here. So what does that mean? It means that in C++, whenever you do the ampersand sign, that will always point it to the address. That is how you define the pointer. Okay, this is basically, pointer is nothing but the evaluation of the reference to an operator, to a variable. Okay, that's the pointer. Now if you put a star ahead of pointer and print it, that means you are referencing. When you print this one, you are referencing something. When you do a star, that means you are dereferencing that pointer. Means dereferencing means you are no longer printing the address, you are just printing the value, actual value. So this is called here, this is called referencing, and this is called together star ptr, this is called dereferencing. Here the an and operator, ampersand operator is called reference operator, whereas the star operator is called dereferencing operator. Any question around that? You have to just remember this one. If you remember this basic principle, if all coding will be super easy with the pointer. There are a lot of confusions around the pointer, but if you understand this simple law, that if you put an ampersand, an ampersand, that means the reference. If you put a star, that means ahead of a variable, then that is means dereference. Means dereferencing means you are printing the actual value. That's how it is supposed to work. So basically you can call it dereference operator or indirection operator. I mean, whatever name you call it doesn't matter, but it does the same thing. So we are done with that. Now the relationship between arrays and pointers. So we are I mean, we are again raising the arrays and pointers. These are extremely important. So the relationship between the arrays and pointer is as follows. The array name is the name of the array is starting address of the array. So you have the vals. I mean, you can say that starting address of vals is this one. So if you simply, so let's do the programming. I mean, you don't need to do the programming. You can just look at it, and we can write the program later. But if you do see out of these vals, without any like any index, then it displays this one. That is the starting address, the address of the value 4. This is the starting address. So you get this one. But if you do see out val 0, 0 means starting address, then it displays 4. That is the basic concept of array and pointer. So the pointer, if you just write the name of the array, the name of the array, then it is pointed to the first variable of the address, to the first variable of the array. This is internal to the C++. You don't have to define it by your hand. So the array name can be used as a pointer constant. So if you do that, it will now you use the dereference variable, and it will display simply 4. So your array is there are 3 elements, 4, 7, and 11. You use the dereference operator, then it will display 4. The pointer can be used as an array name as well. So you can do like int this one. You can initialize in this way, and if you do just I mean, if you just use this one and pass the actual variable, then it will display 7, the second one. So array and pointer is a different story. I mean, not different story, but it's a more like compiler centric story. I mean, there is a lot of things going on inside the array. First of all, array name can be used as a pointer constant, so this way. And secondly, pointers can be used as an array name. So you have this pointer, it can be assigned as the array name. And in that case, if you want to just find out the value of the any operator, you will just pass the index here, and it will display everything. I mean, it will display whatever value without fetching the actual value. It will point it to the reference, to the memory address. That's how the arrays and pointers are related to each other. Now, the array name, let's say, I mean, we already did this program by ourselves. So if you do that, um, not really, we have done this program. Let us, we started probably, but we headed to a different direction. Let me see. Uh, so here, what we did here, P2, here, yeah, that's right. So basically, what we did here is we took advantage of the array name. So this is the address, this is the reference to the first variable. Reference to the array means reference to the first element of the array. The memory reference of an array to an array is nothing but memory reference to the first variable of the array, nothing else. So if you have this one and then you dereference numbers, because you use array name as the pointer, now you dereference this pointer and you get the first, I mean, basically you get the first variable of the array. I mean, you will get 10 here. So if you run this program, let us say, let's simply compile it again, P2. So this one, and let's run P2 again, and you will see 10, the first one. So basically you are using the array name as the pointer. This is an example on how you can use the array name as the pointer, and then you dereference the array name to retrieve the first value of the array. So this is an example for that. Now, you can use pointers in different expressions. So like for example, in a quiz you may be asked that what is the, you define it in this way, okay? So int vals, and then you have int val pointer, and val pointer equals this one. So you are defining an integer array, and you are also defining a pointer to an integer variable. So you can do val pointer equal to vals. That means you are already referencing to this number. That is the advantage with the array. When you define an array, your first element rules. Your address to the first reference to the first element is the pointer to the total, the whole array. So then what you can do here, what is val pointer plus one? So it will display simply 7, because you are incrementing it to the next value. So val pointer is never ever this one, this guy is not a variable. It is a reference to a variable. It's a pointer to an integer variable. So once you increase the pointer, means you displace the pointer by 1, you get 7. If you do it plus 2, you will get 11. So you must use the parentheses as shown in the expression. You cannot just do star val pointer plus 1 without any parentheses. That will not give you any result. You must use this one, this parentheses here. So this is another rule. How do you use the pointers in the expressions? This is nothing but some discussions around the pointer arithmetic. Okay, any questions so far? I mean, you can always interrupt me during the conversation, and I will be happy to answer your questions. So, so then there is a special. So far, I mean, we clearly understood that array is something special in C++ in terms of the memory management. Why? Because the arrays are basically, what happens with the arrays. The arrays are very very memory sensitive data structure, because when you define an array, in principle you can store 1 million variable. I'm just telling 1 million as a reference. You should not define an array with 1 million, like 1 million size. That will deteriorate to your performance. Sometimes that may crash your program, but it can hold multiple values. So that's why memory management is so important. And C++ compiler makes it in a way, it happens at the very low level. It doesn't happen at the high level at your programming language level. It happens at the whenever the compiler, the object that you create, exe file, that object file you create, that interacts with the underlying operating system. At that level it happens. So you have the array elements. It can be accessed, for example, in many ways. So you have the array name, and this is the easiest way. Let's say you have the pointer to the array and the array structure. So you have the value pointer and two. I mean that can also give you the address. I mean to the array. You can do the this pointer arithmetic. You can just like this. I am talking about this array. When we talk about the array, we are talking about some array, not this one. I mean not the previous one. Some array that has three elements, the third element being 17. So here value pointer 2 is 17, and then you can do the vals equals, basically you can say like in this way. You do you have a vals array. you know Suppose you have 5, 10, and 17. I'm talking about this scenario. And then you do val ptr equals val. That's your pointer. So if your val ptr is like that, I mean just this one. So this is pointed to the first element. Then if you do val plus vals plus, I mean these vals, sorry, not um, just a second. So you have the vals. Yeah, of course. I mean, you can do val ptr plus 2. That means you are displacing the pointer by 2. So you are pointing it here. So that will give you this one. Or you can just use the vals. I mean, you don't even need to define any pointer. You can use the vals, the name of the array, and then it displace it by 2, and you will get the same number. So there are multiple ways you can access the elements of the array. You can do it by indexing. You can do it by the memory. So, um, so all these things will produce the same results. I mean, these are very hot favorite topics for the quiz questions, where you may be asked that, I mean, different options and what are the right, what are the what are not right. I mean, maybe it's a multi-select question. You will be given this one and this one and two other bad, I mean, wrong answers, but then you have to select these two. So that's, I mean, just some exam pop-up kind of thing. So, I mean, the conversion you do here, vals I is equivalent to vals plus I. You have to remember this because of the pointer arithmetic, you know. So if you write the program, let's write the program so that you see it how what is being done here. So basically, what I'm saying here, if you write, let's say, see out um, numbers, okay, let's say 2, what will be the value of this? So the value will be 0, 1, 2, 30. Let's see. I mean, I'm just deleting this one. If we do that, and then if we run the program, so you can see 30 is printed here, this value. Now, instead of writing this one, you could have written cout, then you use the star dereferencing operator. You can say numbers plus, let's say 2, okay, end line. That would give you the same result. So that will also give you 30, same 30. That's the beauty of it. So no bounds checking performed on array access, whether using array name or a pointer. I mean, you can do it in any way. It is not going to affect any performance, anything. So this is a different way of accessing the array. So I think we are good with that. Now, I mean, we are doing more specifically pointer arithmetic. It's very important. It's extremely important. So what I want now, let's move on. Let's start it. Then we will give a break. So you have the operations on pointer variables here discussed. So your operation is, let's say, increment operator or decrement operator. Plus plus is basically plus one, right? You have this variable in place. Now this one will be pointing that way. The array will be pointing at 7 because you are incremented by 1. Now once you do that, after that, if you do this one minus minus, so it will be pulled back to the original position. So it will be pointed at 4. Now, plus minus pointer and int, basically, if you do this one, we have already done it. We are just summarizing this one. So if you do that, val pointer plus 2. So val pointer again, it is this one. So if you do that, then it will be pointed to 11, right? I mean, it is val pointer by definition, it is pointed to 4. Then if you do plus 2 with a dereference operator, it will be pointed to 11. Now, if you do plus equals, I mean increment by some number 2, let us say. So if you do that, I mean, first of all, this one is pointed to 4, of course, because vals is the first element of the array. Then val pointer plus equals 2 means it is pointed to the third element of the array. And minus from pointer to pointer, if you do val pointer minus val, uh, I mean, this is the difference, the number of ints between the val pointer and val. So that's your another reference. I'm just asking you to, whenever you get time, just try to execute this example. Just write the program sequentially, this one. Just write the program, just define this one, then you define all the steps. Then you will see how things are evolving. That's a good exercise, good learning exercise for you. So, um, so I don't want to spend time in writing this code because it's already there, and this is what you need to write yourself. If you write it, you will understand the full significance of that. So with that, let's give a 10 minutes break and let's come back around 8:10, and we will go through the next part of the pointer. Welcome back. So, any questions so far? Okay, let's move forward. So now we are going to discuss about the initializing of the pointer. Uh, I mean, you can initialize a, I mean, whenever you have the pointer, you should initialize it at the point when it is defined. I mean, if you don't define it, that will that may give you some unpredictable results, inconsistent results. So basically, typically what I would do, I would define a pointer like this: int, let's say, pointer ptr, and then I will initialize it to null pointer. So that will be the starting point, and then you can I mean, of course, you can initialize it with anything, but this is the safest way. You define it in this way, and then you can just do like this: pointer equals num. That way it will be assigned to the value of the address to the number, whatever number we are using there. Anyway, whatever variable, whatever number we are using, we can do that. Okay, so I mean, we have done the good uh, like a sizable amount of pointer arithmetic, but then we have to understand that we are now doing the initialization of the pointers, and you have to, I mean, this is the way you should initialize, but then you cannot mix the data types. Like, you have a double variable. Now you cannot write it in this way. This means the pointer, this guy, this is a pointer to an integer. But right now, what you are trying to do, you are assigning an address to the double. This cannot work. This won't work. So you can test invalid address for pointer with this one. I mean, basically, if you want to test an invalid address, then you should use this one, this particular way. Like, I mean, let us write something up. So let's say we have this code, and now what we want to do, basically, we can go back to here, this one. Okay. Now you have, let's say, double um, z equals 5.01. This is a double, right? Now what we can do, if we do like, let's say, int pointer equals z, if you do try to do that, and then I'm just deleting this one, these two. This won't compile actually, because you see here your visual V- VS code itself will show an error. It will say that a value of type double cannot be used to initialize an entity of type this one. So that's pretty much it is. So if you do cout, and then you do there is no question, this program will not compile simply. There will be a compiler error. So there is no question, so you cannot do it. So if you want to compile this, let's say p1, right? So you will get an error. So if you try to do that, you see this is an error. You cannot do it. So that's pretty much it is. Now you can compare the pointers. So this one, the relational operators, this one, these things can be used to compare the pointers. Now, if you do this one, this equation equal operator, equality operator, it compares the addresses only. You have to remember, like you have, for example, let's say you are doing this. I mean, I'm using this code as our template. So let's move away from that. Pointer one, equals, let's say, x, and if we do pointer 2, sorry, pointer 2 equals, let's say, sorry, oops, equals x, and then if we have pointer 3 equals reference of y, then what happens, let's say if we do if ptr1 equals ptr2, we can say c out uh, p, you can say that same address. I'm just making it very simple and short. So then here we can do also if ptr, dereference ptr1 equals dereference ptr3, right? Uh, let's say let's say this is also 25. Okay, dereference ptr3, we can say c out uh, values are equal, and then just to check same value but different memory address. So if we do like same thing here, sorry, same thing like that. I'm just maximizing the screen so you can view it fully. So ptr1 equals ptr3, let's say. So basically what happens here, you have two variables, 25, x equal 25, y equals 25. You have a pointer pointed to x, this one. You have a pointer 2 pointed to x, the same variable, same memory address. Then you have pointer 3, which is pointed to the different variable. Now, will the pointer 1 and pointer 2 be equal? It is likely that they will be equal because they are pointed to the same variable. But will they be equal? The values, pointer 1 and pointer 3? Yes, they should be equal because pointer 1 is x and pointer 3 is pointed to y. They are equal valued. But if pointer 1 and pointer 3 are equal, means x and z, x and y addresses, they should not be equal. So you can say, like, you should be able to see here, if you embed an else statement here, you should be able to see that see out, uh, you can say not pointed to the same address. Okay. So now if you do that, now this is P1, right? We can use the P1. Sorry. Yeah. So if you compile this one and then if you execute this one too, so then you can see that this is the same address because they are essentially pointed to the same variable, exactly same location of the memory. The values are equal because you are dereferenced and found values are equal. But you see here the pointer 1 and pointer 3, y and x variable, their values are equal, but they are different variables. Therefore, they are pointed to different memory locations. So we are getting this condition not pointed to the same memory address. So that's how the equalities in the pointer work. Okay. Any question? So you can use the pointers as the function parameter. So you have to use the asterisk for that. So a pointer can be a parameter, first of all, you know, the works like a reference variable to allow change to argument from within the function. So you have to use the asterisk here. Now you can say the get number, the pointer is pointed to an integer. Now what you can do, you can simply, let's say you are um, let's write the code, that way we will understand it better. Let's do it hands on. Okay, so let's write it in the code. So let's do it here. So let's create another file. Let's say p4.cpp, and we can simply copy paste this skeleton, and then we can do return 0. And this is the skeleton, this is the shell of the program. Now what we can do, we can define a function void, let's say get num, and then you can do int star x. Okay, this is the prototype. Now you come here, and then what you can do is basically you can call this number. Let's define this function first. So let's do it in this way. Okay, so we can do cin, um, let's say x. Okay, cin, sorry, x. We are doing it in this way. So we are basically reading something, and we are at the same time storing into a memory where the x will be located at. Now what we can do here, we can say int um, y. We are not defining it, initializing it. Now we can say that basically get num. Okay, and then you pass the reference and sign, and you can say x. So you are basically sorry, not x, it should be y. You are basically passing the reference to this variable here. Now at this point, if you do cout, and if you try to print y, let's see, I mean, you should be able to print whatever you are inputting here. You can do cout, enter the value of x, right? So it will ask you to enter the value of x. So this is the whole program. You have the include, I mean, these are the standard stuff. Then you define the prototype of the function. Once you define this, you define the main function. This is the real function where you are basically you are asking to enter the value of x. So you are entering the value of x, you are dereferencing it. Then you just pass the reference, and then let's see how it works. I mean, if it works at all, and if it works, then how it works. So let's try to compile p4, and then p4 dot slash p4 dot exe. If we do so, let's enter the value of x, let's say 100. So you see that we can enter the value. So what is happening here, in the memory space you have a value. Let's create some snippet so that we can use that as our blackboard. Okay, let's get it here. So what it is doing, we are uh, we are defining an integer y. So here is our memory space, virtual memory. Okay, now here you are defining integer of a variable y, integer variable. So this variable, it is uninitialized, but it is stored in this memory location ABC. I mean, I'm just arbitrary. This memory location. What you are doing, you are defining a get num function with a pointer variable to that integer x. So that means your get num is pointed to the to a variable which is whose memory location will be passed here. So what you do here, you just do the get num and then pass by reference. Then what you do, what it does, it basically, it basically whenever it is executed here, whenever it is executed, it goes to here, fetches the variable, sets the value of this variable here, and then it prints it here, line number 9. So that's how it gets, I mean, you are entering 100 and getting 100 out of that. So that is another example of how you can pass a pointer to a function. So another cool example that you are going to use in many times, you have already used actually. If you have written programs for the bubble shot, many of you have written. So you have already used, but we have not used at that level. So basically a swap function, it's a classic function. This one is used extensively in C++, in practically in all every other programming language you use this function. So basically, you do it in this way. You define a function called swap. So what is the purpose? You have a you have a data. Suppose you have a data structure where you have x and y, two variables. So what you want to do? You want to shuffle. You want to put y here and you want to put x here. That's the thing you want to do. So what you do? You define a temp and you are passing the pointer to this variable. So instead of the actual variables, you are passing the memory location of those variables. Then you define an integer and then you use the dereference variable, dereference to this pointer, temp, and then what you do, you are equating x, I mean dereference x to dereference y. Everything is played with the memory. You are not playing with any actual value. You are not passing by value. You are saving a huge memory there. So then you are equating this guy to temp. So at the end of the day, suppose you do this one, num1 and num2, then you swap, you call it like this. You are passing the reference. Your output will be num1 should be your output. As an output, your num1 should be -3 and your num2's value should be, after this step is executed, this should be 2. So that's how you can use the swap using the pointers. Okay, and in case of solving the problems with the data structure, this example is very useful. So just pay attention, special attention to that. So I'm not going into this one. That's not well, I mean, we did that. I mean, like we have already used this one in some form. So uh, you can use the pointers to constants. So if we want to store the address of a constant in a pointer, then we need to store it in a pointer to const. Okay, so how does it work? So here, so suppose you have the following definitions, like you have this size, this one, and your, I mean, suppose you have the pay rates, I mean, these things are there. Now in this code, pay rates is an array of constant doubles. Okay, these are the constant doubles because you see here constant. So now how do you use pointer here? Suppose we wish to pass the pay rates array to a function. Here's an example how we can do it. So basically you do constant double pointer rates and size. Then you simply do what? I mean, you do count less than size, whatever the size of the variable, but then you are executing some pointer arithmetics. These rates, this is an array, right? When you do the rates, you are pointed to the first element of the array and you are displacing it by 1. So basically you are getting all the values, you know the I mean, all the values, you are displaying all the values one by one, which is referenced here. Okay, so that's how you should uh, you should do it. So you have to use the keyword constant here. So declaration of a pointer to constant. So basically the asterisk indicates that this is a pointer, of course, but then you have to use the constant, this one, this guy, this keyword. If you don't use this keyword, then it won't be a constant. Then you will get inconsistent results, or the program won't be compiling itself. You can try it, but this is the key. You have to use the constant pointer. I mean, constant double or constant integer, whatever the variable type you are referring to, you have to use that. Okay. So the constant pointer is a pointer that is initialized with an address, and it will not change. It will not, it cannot be pointed to anything else. So any example that we can come up with for the constant pointer? I mean, such a variable which will be constant throughout the life cycle. Any example? Can anyone say about any example? Uh, you can put it in the chat box. Suppose, giving you an example, helping you. Suppose you are a programmer at City of Los Angeles Department of Motor Vehicles. Okay. Now let us say you are writing some program where the city name is essential, and this is a program, proprietary program to the LADMV. I mean, so then what will be the city name? It's Los Angeles everywhere. You don't have to use a dynamic, you don't have to use a uh, dynamic variable for that. This should be a constant. So you can say constant string, and then you can say it as the Los Angeles. Constant string city Los Angeles. So that is an example, classic example. So in that case, you should use this const keyword. That's it. So const indicates that pointer is a constant pointer. So it cannot be changed afterwards. It cannot be pointed to Las Vegas after some time. I mean, after some steps in the program, it will be pointed towards Los Angeles only. So that's pretty much the indication. I mean, that's the requirement for a constant pointers. So it is exactly same thing like your variable declaration, but the difference is that in case of a variable, the value of that variable cannot change over the life cycle of the program because it's a constant. But in this case, it's a constant pointer. So the memory address, memory location, the variable, the pointer won't be, you cannot, the pointer won't be set, or you won't be able to set the pointer to another address. So it has to be constant throughout the life cycle of the program. That's the requirement. So a constant pointer to a constant is a pointer that points to a constant. That's absolutely right. And a pointer that cannot pointing to anything except what it is pointing to. So you have this one, you have this one. So that means it will always be pointed to this value. I mean, the address, I mean, the value, you have the memory, right? The classic memory diagram, the virtual memory. So you have value equals 22. I'm just writing B 22. This is the memory address. Let's say X, F, Y, Z, 0, C, and something like that, some hash code. So if you declare pointer like this for the life cycle of the code, this guy cannot change. This address cannot change. So this will be pointed to this variable throughout the life cycle of the code. Okay, so that's the point here. So the constant indicates that pointer is a constant pointer. Always remember, I mean, it's not like the value is a constant. I mean, this here, this int value 22, it's not a constant value, but the pointer is the constant. A value can change, but the pointer cannot change. That's the idea. Now, next topic is dynamic memory allocation. This is by far very important in C++. So you can allocate storage for a variable. When you do the dynamic memory allocation, you can allocate storage for a variable while program is running. So um, you can allocate and deallocate the pointer to a memory location during the runtime of the program. So computer returns address of newly allocated variable in that case. So in that case, you use the new operator to allocate memory. So suppose you have this one, you create a pointer dptr, and it is pointed to the null pointer to begin with, but then you create a new double, so new returns address of the memory location. Okay, so it is called dynamic memory location allocation. So it can also use new to allocate array. So for example, you have a array of size 25, you can do an array pointer equals new double size. So basically you can do this. I mean, then your arithmetic is pretty much the same. But only thing is that um, only caveat in this type of dynamic allocation is that this one, the program will terminate if not enough memory available to allocate. So what does it imply? It means that if you use the dynamic memory allocation, you have to be able to deallocate those memories. If you don't do that, then your program will eventually terminate because all the memories are pointed to, I mean, all the new, every time you are creating a new, new pointer, dynamic pointer, that means your, so first iteration, this claims this shell, this same thing. Next iteration, the same thing will be pointed to another shell. So at some point, you will be out of memory. So then your program will crash. So what you do, you need to clean up the memory. As you are done with the programming, you clean up the memory and then you start the new dynamic allocation. That's the cleaner way to do that. So how do you release that dynamic memory? By the way, you need to use the delete to free the dynamic memory. So you have to do delete whatever pointer or delete the array. So only use the delete with the dynamic memory. You should not be using delete with the static memory. I mean, static pointer, normal pointer, you should not be using not, you should not be using that. You should be using delete only with the dynamic memory. Okay, so that's another definition of dynamic pointer. So let's see. Um, let's try to get into some program like that. I mean, let's start up our programming window again here. So let's create a new program. I'm just demoing something related to the dynamic pointer. So let's say uh, dynamic.cpp. Okay. So first, let's do include. I mean, let's do some includes here to begin with. Now, this program, what it does, I'm going to write a program. I mean, as written in the slide, that totals and averages the sales figures for any number of days. So there's come the dynamicity. Okay, the figures are stored in a dynamically allocated array. So what we do, basically, you start by writing the code. I mean, like you can do int main and then you can do return 0, close it. Now what you do, you you define the number of, you define the cells variable. Let's say, let's first declare the variables. So you have the cells, it is the dynamically allocate an array. So cells is an array basically. It is now towards a null pointer. Total number is 0 for the cell. Average, we don't know. It is defined just. And then number of days and counter variable. So that is your variable declaration. Now you can do the get number of days. How many number of cells, number of days of cells figure do you want to enter in your program? So you can do is like that. How many days of sales figure do you wish to process? So number of days you are writing here. Then you need to create a dynamically allocated array. So how do you do that? So you have the cells right here, cells. So you can do cells equals new double. So it's a double variable. So new double number of days. So every time you enter a new number of days, you will create a new cells, I mean, new cells array, new pointer. So for each day, you can find out the cells figure right now. Now you can look for the cells figures. This can be done by getting the data in this way. So get the sales figures for each day. You do like enter the sales figures below, and then you do for loop, number of days, and count is there already here. So count is less than number of days, and then you just see in, basically read the sales records, manually entering the sales records. So how do you calculate the total sales? It's pretty simple, you know, because you are allocating the cells, this one, this guy, dynamically allocating. So at the end of the day, you can run a for loop and sum up, right? So total, you have a variable named total somewhere here. So you are totaling them, each of the, you are just, this is a trick to do derive the total, right? Then what you do, you calculate the average. You calculate the average. It's very straightforward. You can do average equals total by number of days. So daily average. Now you can display the results, right? That is fine. I mean, up to this point, it is super. I mean, even your program will run up to this point without any problem. If you just compile it, it will run smoothly. So just for the sake of example, if you do G++ dash O dynamic.exe dynamic.cpp, it will compile. It will not do any complaint. But the problem is here. Problem is you are creating a new sales operator. I mean, dynamic pointer here. So if you don't clean that pointer, suppose what happens if you are repeating this program through a while loop, I mean, you process 5 days, then in the next iteration, you are processing for 10 days, then 15 days in the single run, then your memory will keep accumulating. So what you need to do at the end, basically, you need to um, delete the cells. You are deleting, and then once you delete it, it will, if you delete the cells, basically it will delete all the memories from it, but it will not deallocate. It will not deallocate the pointer. It will delete the memory, but it will not deallocate the memory. This one, there are two things going on here. You are creating memory as you are going through the calculations. That's number one. Number two is you are allocating cells to a definite memory location. In order to deallocate that memory, what you need to do, you need to set it to the zero memory location, that is the void memory location, by simply setting it to null pointer. So what we did here, we created a dynamic memory, dynamic pointer. We did the programming, and finally we delete the cells, and then we point it to the null pointer. So we delete the memory, and then we deallocate the memory. We delete the data from the memory. So we have reduced the memory, but still the memory cells are occupied by this pointer after this step. After this step, cells pointer is occupied by those memory cells are not flashed at this point here, line number 39, they are all reset. Okay, so that's how it works. And now if you want to run the program, let's run it. So if you do that, and then if you do uh, dynamic.c, sorry, exe, so how many days? Let's say 10, let's say 3 days, make it simple. So sales figures, let's say first day 20,000, second day 25,000, third day 15,000. These are the dollar values, let us say. So you see the total sale is of $60,000 and 20,000 is the average sale. But the main thing here is clearing, creating of the dynamic pointer and clearing the dynamic pointer. That's the main thing here. Okay. Any question so far? Okay, we can proceed. So that's what we did. Next thing is the returning pointers from functions. That is important because you can the pointer can be return type of a function as well. So in that case, you can do the function in this way. Int this one. The function must not return a pointer to a local variable in the function because the local variables they don't have any reference in the global scope. That's why a function should only return a pointer to data that was passed to the function as an argument or to dynamically allocated memory. So if you go through this program, I'm not writing this program. So this one is returning a pointer to the integer. So what it does, initially it creates an array, but it is pointed to the null pointer. I mean, it's initializing the pointer. Then you just, if the number of elements is zero, I mean less than equals zero, it returns a null pointer. But then otherwise, it simply dynamically allocate the array. Then it creates the random number, of course. And then, I mean, this is the initializing the number of random number generator. Then you populate the random numbers this way. Then you return the pointer to that array because you are populating it against that array. See here, and then you are just returning that pointer to the array. That's how you can return the pointer. The main advantage of doing it is that you are creating the array dynamically in the memory space, but then you are returning it so that you can use it subsequent at a subsequent time. So there is another, you can use the smart pointers to avoid memory leaks. So basically, you know, there are three kind of smart pointers. Here, when you deallocate the pointer here, this one delete. If you don't do these two steps, this will lead, if you don't do it, this will lead to leak of memory. Leak of memory means the memory will be, unclaimed, and you won't be use the full memory of the system. Eventually your program will crash. So you can prevent that using the delete operator, or you can use the smart pointers as well. So the smart pointer is starting from C++11. So there are three types of smart pointer. Number one is unique pointer, number two is shared pointer, number three is the weak pointer. So you have to include the memory header file, this one. So you can use the unique pointer. I mean, we are focused on the unique pointer only. So it is defined in this way. Let me see if I can find some example for the unique pointer. Yeah, we can do that. So let's create a program, new program. Let's do it like unique ptr dot cpp. So as usual, we are starting with these two elements. I mean, these three elements. In fact, we are using the memory as the include function. So we write the main function, of course, like this, and then return 0 and end. That's it. This is shell of the program. Say we are setting some maximum size of the array this way. Okay. Then we get the number of values to store. How many? What is this maximum size? So you can do that way. Just see in this number. You asking your user to input that. Now you define the unique smart pointer. So the way you define it, the syntax is like this. You write unique pointer int. This is the typecasting. This is called this unique pointer has a type of integer. Like usually what we do. Usually you could do int star ptr equals null pointer, right? You could do that null ptr. So this is something like that, but it is I mean, it is coded inside the variable declaration. So you define it in that way. Now you can get the values of the array. You can just now onwards, you are using it as a normal pointer in the C++. So you do this one. Then you display the values. Okay. So there is no more delete necessary. Why? Because it is taken care of within the framework itself. It's easy and you can use it in this type of use cases. So you can say unique exe unique pointer cpp. So you do unique pointer exe. So you can how many numbers you want to enter. Let us say 5 numbers. So you do 1, 2, 3, 4, 5, and you display the numbers. It works. But the thing is, the main advantage that you get by using the unique pointer is that you don't have to mess with the delete stuff. That is a very good advantage of using the unique pointer. You know. So, I mean, that's a smart pointer basically. So here, let's go into deep dive. This notation indicates here we use the integer array in our programming case, but here it is used as integer as an example. It indicates that the pointer can point to an integer. The name of the pointer is, of course, the pointer, and the expression new int allocates a chunk of memory to hold an integer. The address of the chunk of memory will be assigned to a pointer here. Okay, that is the implication step by step. So if you once you do that, I mean, this is the program. It's similar to what we wrote, but it's simpler. So you define unique pointer, you have to use this include memory. Then you define int pointer this way. Then you assign 99 to the dynamically allocated integer. So you use dynamically allocated memory. So you use it there, you display it. No delete business anymore. So that's all about the pointers. So what we learned today, if we want to summarize, we started with the referencing of the variables. Then we quickly jumped into the arrays discussion into the arrays. I mean, how the arrays are related to the pointer and reference of the variables. Then we talked about the pointers in details, the asterisk, the star symbol. I mean, the by using and symbol, you are doing the referencing, and using the star symbol, you are dereferencing the variables. Then we talked about how we can use the pointer arithmetics in case of the arrays. That is super important in C++. And then we went through some lot of examples related to the arrays, and also we came after the constant pointer. We talked about the dynamic pointer. Dynamic pointer requires clearing of the memory. So that can be done using the delete operator, I mean, delete keyword in C++, or you could use a smart pointer like we referenced here, unique underscore PTR. This happens only after C++, sorry, um, no. So if you do this, so only after C++ version 10, these smart pointers. For the smart pointers to work, you have to reference memory, include the memory, and you have to define it in this way. We have only discussed the unique pointer in this class. So that's all about what we discussed today. Um, any question, any question related to your homework, things like that in the previous week? If you have any question like that, I mean, you are more than welcome to send me a message. I will reply to those messages within 24 to 48 hours. Or you can request for an office hour so that we can go over those points. So again, I mean, any final questions, comments, concerns? Don't forget to fill up your quizzes. And I think that's all I wanted to present today. Thank you for joining today's class. I will see you to next week, unless you have any, you want to use any office hour this week. Uh, you can always, I mean, office hour is ad hoc. I mean, you can ask me for some time and we can schedule something as per both parties, I mean, myself and your convenience. But I will try to schedule, dedicate some time towards the office hours from the next week. And next week, always remember that we have a pop quiz in the syllabus. So next week will be maybe, I'm not will be, maybe we may have a pop quiz in the next week, but it will be an easy pop quiz. Don't stress yourself out. It will be super easy. I mean, the content of the pop quiz may be whatever we have learned so far. So it won't be very heavy. It will be simple. If you just follow some slides, some very simple slides, simple preliminary concept, basic concepts, then you should be good with the pop quiz. So if you don't have any other question, then thank you for participating today's class and see you tomorrow. See you next week. Sorry. Thank you.